This is the first in a series of videos on confidence interval of means, and this series of videos comes after a series of videos on confidence intervals and confidence intervals of proportions. So first, let's think about population mean and a sample mean. So the first thing we're going to do is we're going to assume that we have a random variable, and we're going to call it x for convenience, where x is distributed with an unknown distribution or an arbitrary distribution with mean mu and standard deviation sigma. Then, under certain conditions, the following is true. X bar, the sample mean, will be distributed normally with mean mu and standard deviation sigma over square root of n. And so, though we use this over and over again, we want to make sure we always remember exactly what this means. What this means is the estimator x bar will be unbiased. That is, on average, it'll give you the true value of the sample mean on average will be equal to the population mean, and the standard deviation, the spread of the estimator, will be related to sigma by sigma over square root of n. So what we're going to do today is, given that information, we're going to calculate a confidence interval, and let's just use an arbitrary number, k% confidence interval. For mu. And this k might be, for example, 80% or 90% or 95%. And what we're going to do is we're going to end up with a range of estimates for mu, of which we're going to have a certain degree of confidence that the true population mean mu will fall within that range. And let's review real quickly about confidence intervals. Confidence interval is equal to the parameter estimate plus or minus the margin of error. And the margin of error is going to have two components. And the two components are a critical value that depends upon what degree of confidence we would like, and the standard error. And in this case, since in the simplest case, when sigma is known, this is going to simply come from a z-table. So it's often called the z-critical value. And for the case of x bar, we know what the standard error is going to be. The standard error is going to be sigma over square root of n. And we can think about what is important in terms of how large the margin of error is. It's how sure you want to be, what degree of confidence you want, how much randomness there is in the population, and what the sample size is. So let's go ahead and do an example. So in our example, let's say we want to come up with a 90% confidence interval. And we know that sigma is equal to 23. We're going to calculate an x bar. Our x bar, let's say, is 205, and we got that from a sample size of 150. Well, our formula here is the confidence interval for to be 90% sure, a 90% confidence interval, is equal to x bar plus or minus the critical value, let's call that z sub 90, times the standard error, and the standard error here is going to be sigma over square root of n. So now we start plugging in numbers. our X bar will be calculated from our sample. In this case, it's 205. The Z is going to be calculated from a Z table. And let's think about that just for a second. If we want to be a 90% sure, that means in the center of the distribution we want 90% to fall, which means in the two edges we want 10%, which means in any one tail we want to be 5% or 0.05. And it turns out we can either get the positive or the negative critical value. It doesn't matter because we're going to do plus or minus. So let's look at our Z table. For our Z table, 0.05, if we look for the closest one to 0.05, it looks like it's going to be right here. That's the closest we can get, and that's minus 1.64. So this will be plus or minus negative 1.64 or positive 1.64. It'll be symmetric. Sigma here is assumed to be 23, and the sample size is 150. And now it's just a matter of plugging numbers in. If we use our calculator here, I'm going to do this part first, 23 divided by parentheses 150 raised to the power of 0.5. Be very careful with your parentheses. And then you're going to times that by 1.64. And you get 3.0798. Let's round to 3 decimal places. That's 3 decimal places with 3.08. And then you do plus or minus. Let's just do that. 205 minus your answer is going to give 201.9, 201.920. And if you add it, I can actually do that in my head, that's 208.08. So that's going to be your 90% confidence interval. Let's go ahead and do a 99% confidence interval and see how that would change. Everything actually would be exactly the same except for your Z-score would be different. So let's look at that and let's look at your Z-score. So let's actually just move this up and start right there. But let's do a 99%. A 99% confidence interval will be X bar plus or minus Z.99 sigma over square root of n. The sigma square root of n is going to be the same thing. That's going to be 23 over the square root of 150. But now let's think about a 99% confidence interval. In that case, we want 99% here to be in the center, which means you want 1% to be in the two tails. So this wants to be at 0.5%, which is 0.005. And this over here is 0.005. So if we look at that, 0.005, there's 0.001, 0.006, 0.0 minus 3.29. And our X bar, remember, was 205. 205 plus or minus. Let's multiply that. We have 23 divided by parentheses 150 raised to the power of 0.5 and times that by 3.29. And you get 6.17. And you really get a sense, 6.18 really. And you really get a sense of how. Now let's think about that. We went from a 90% confidence interval to a 99% confidence interval. And our margin of error before was 3.08, and now it's 6.18. So our margin of error about doubled. And if we subtract here, this would be 198.82, and this would be 211.18. Now I did this in my head, so let me make sure that that's right. 205 minus 6.18, 198.8. That's right. And that's how you do a confidence interval with means.